Our second lesson is going to be about angles. You've studied angles for a long time, and you know angles as degrees. And we've talked a little bit about degrees, minutes, and seconds. Today, we're going to talk about a different way of measuring angles, and this is called the mathematician's way of measuring an angle. And that is called a radian. So, the formal definition of a radian is this. 1 radian is the measure of the central angle of a circle subtended by an arc equal in length to the radius of the circle. And that is so complicated, but let me just break down what it says. Let's start by drawing a circle. I'm going to cheat and use this nice circle option here. Actually, let me move it right here. And it puts the center right there. I'm now going to draw an XY axis right through the center of that circle. Here's my Y axis, and here is my X axis. And let me label those. Okay, so we have a circle with its center right at the origin, 0, 0. And now let's break down this definition. 1 radian is the measure of the central angle. Remember from geometry, the central angle is the angle at the center of the circle. So it's the measure of that central angle of the circle subtended by an arc equal in length to the radius. Subtended is a fancy word that just says if you have an arc on a circle, there's some central angle associated with it. So if I draw an arc right here in purple, an arc of the circle, there it is, an arc. That subtends some central angle from here to here. Good? Now, a radian is that measure right there if that arc happens to be equal to the radius. So remember the radius from the center of the circle. If that is r, and this distance right here would also be r, if the length of this arc is the same as the length of the radius, then that angle is 1 radian. And that's all it means. That's all a radian is. It's the measure of the central angle of a circle if the radius is the length of an arc, the angle associated with that arc. Now, let's look at some more examples, given that my artistic skills are somewhat lacking. So, here's another picture of 1 radian. Notice that it says alpha equals 1 radian. We often use Greek letters to measure angles. This time we're using the Greek letter alpha. It's where we get our letter A from. Alpha equals 1 radian. Notice alpha is at the center of the circle. The length of the arc there is r, the same as the radius. Okay? Another example here. Beta equals 2 radians. We have the angle beta at the center of the circle. The radius is r, and it's showing you that the arc length has a length of 2r. The arc from A to P is 2r. Good? Another picture, similar idea. We've got gamma. So it's hard to see there, but it's kind of written like this. Looks like a Y. But it's often, it's kind of associated with G as well. Anyway, gamma at the center of the circle, the radius is r, the length from A to P would be 1, 2, 3 of those radiuses, or radii, so gamma has a measure of 3 radians. Let's try to get a sense of what a radian is in degrees, and it's actually easier to do that with something we know in degrees. So let's take the entire circle. So if I draw the entire circle, and we think about the angle here at the center that starts here and goes all the way around back to itself, that would be 360 degrees. So now we're going to go back to geometry here. Let's think about this radius from the center of the circle to here, r. The measure of the entire circle in radians would be the distance all the way around the circle. What is that distance all the way around the circle? It's called circumference. And what is that distance in terms of the radius? Well, 1r is here, 2r, 3r, 4, 5, 6r would be close, but it's not quite there. It's actually 6.28 or about. That's kind of rounding. It takes that many radiuses or radii to go around the circle. If we wanted an exact answer, we would say it's 2 pi r. That's the distance. So 360 is actually equal to 2 pi radians. That's a very important relationship, and actually we reduce that by a factor of 2 on both sides, and the big definition here is that pi radians is equal to 180 degrees. So there's your big conversion for tomorrow's classwork. Pi radians is 180 degrees. You'll notice I've been trying to write degrees. Every single time I use degrees, what's great about radians is that you don't have to write units. We often say in mathematics that radians are unitless. You wouldn't lose points for saying something like pi radians, but you don't have to write it. And that's what's so great about radians. They're unitless. They make a lot of mathematics easy. And we'll see that in the next few slides. Let's take a look at this same picture drawn much better than I can. 360 degrees equals 2 pi radians, 6.28 radians. Again, they wrote it here, but you don't have to write it when we're talking about angles. And you can see 1, 2, 3, 4, 5, 6, and a little bit extra. So that's going all the way around the circle and measuring that angle in radians. If we go back to that definition or that conversion factor that I wrote, pi equals 180 degrees. When we're talking about measuring angles in radians, we can say pi radians is 180 degrees. That's a really important idea. So let's write that down. Pi radians, and you don't have to write this, but I'm going to for now, just to get till we get the hang of it. Pi radians equals 180 degrees. Use this to figure out what 1 radian is. If I wanted to find out what 1 radian equals, I could just divide up here both sides by pi, right? If I divide pi radians by pi and divide this by pi, it's an equation. What you do to one side, you do to the other. The pi's cancel. I'm left with 1 radian. And what does that equal? Well, I'm just going to take out my calculator. 57.295779513. 0, okay, you get the idea. It goes on for a while. Actually, it goes on forever. Degrees. And that should make sense that it goes on forever. If we go back to the relationship, that pi radians equals 180 degrees. Since pi is an irrational number and it goes on forever, and 180 degrees is a rational number and it terminates, if we have a radian that doesn't go on forever, like 1, its angle representation will, and so we'll have to round. And if we have an angle that doesn't go on forever, like 30, when we convert it to radians, it'll go on forever, or we'll use it in terms of pi. Good? So 1 radian is about 57.296 degrees. Let's do a little summary here. If we have an angle, we can measure that angle in 2 different units. Maybe you could argue 3. So here's an angle. Let's call that measure alpha. Alpha can be measured in radians, it can be measured in degrees, and it can be measured in degrees, minutes, and seconds. These two, you could argue, are the same units, but let's say 3, and let's talk about how you would convert from any one of these 3 to the other. I would argue that you always go from radians into degrees, and then from degrees into degrees, minutes, seconds. You go from degrees, minutes, seconds into degrees, and then into radians. So I'm going to give us 2 examples. One is going to be an angle that's in degrees, minutes, and seconds, and we will convert it into degrees, and then from degrees we'll convert it into radians. Then I'll do an example where we convert an angle from radians into degrees and then into degrees, minutes, and seconds. I'm just going to make one up. Let's say it's 42 degrees, 13 minutes, and 45 seconds. The first thing we need to do is take this fraction of a degree and convert it into a decimal. So remember from the other day, 45 seconds is part of a minute. How much of a minute is it? Well, it's 45 over 60. That's 3/4 or 0.75 minutes. So now I can actually say, well, this is 42 degrees and 13.75 minutes. Now I can take this 13.75 and I can find out how much of a degree that is by taking 13.5 and dividing by 60. Remember, 1 degree is 60 minutes, so 13.75 minutes over 60 minutes will be that decimal of a degree. So I'm going to take 13.75 and divide by 60 on my calculator. 13.75 divide by 60. Maybe you can do this along with me. If you are, you would get 0.22916 repeating. I'm going to add that to 42, and now I've converted degrees, minutes, and seconds to just degrees. So 42 degrees, 13 minutes, and 45 seconds is the same as 13.22916 repeating degrees. Now we're going to convert this into radians. So to convert that into radians, we need to take our conversion factor, that is pi radians equals 180 degrees. So here I have my 42.22916 repeating degrees, and I am going to multiply by something to change this into radians. If you've taken chemistry, you know this factor label method. You've studied this in algebra. I have a degree up here, so I want degrees down here. I'm trying to get radians, so I want radians up here. And how many radians? Pi radians. How many degrees? 180 degrees. These degrees are units that will cancel, and I'm left with multiplying 42.22916 by pi and dividing by 180. I'm doing this all on a calculator, and when I do that on a calculator, I get 0.737. Just going to round to 3 decimal places. That's 0.737 radians. Okay, so taking a look at this whole thing, we had 42 degrees, 13 minutes, and 45 seconds. That is the same as 42.22916 repeating degrees, and that's approximately equal to, because we rounded here, 0.737 radians. As we said earlier, 1 radian is about 57 degrees. So 42 degrees should be less than 1 radian, and that's what we got. Great. Let's try going the other way. Now I'm going to start with something like 3 radians. So we're going to take 3 radians, and I'm going to do exactly what I just did to get 2 degrees. I'm going to multiply by something to get me into degrees. So I have radians. I'm going to multiply by something here. I want the radians to cancel. So radians on the bottom. I want degrees up here. And remember, you're not allowed to change the value. So we're just multiplying by 1 in a creative way. 180 degrees equals pi radians. The radians cancel. And I'm left with 3 times 180 over pi. And that answer will be in degrees. Again, I'm going to do that in my calculator here. You should have your calculator out and do this along with me. If I take 3 times 180, I end up getting 540, and I divide by pi, and that's 171.887. So that's about, again, I'm rounding, so 171.887 degrees. And that's about. Good? But I'm not gonna delete that on my calculator. On my calculator right now it says this: 171.88733839247. And I'm going to leave that on my calculator when I'm going to change this into degrees, minutes, seconds. I know how many degrees I have. It's right here. So that's 171 degrees. Now everything else right here, I'll circle this in red, everything else right here is a fraction of a degree. So on my calculator, I'm going to subtract 171. When I subtract 171, my calculator now just has this decimal, the 0.887 blah blah blah. I'm going to take that decimal. I'm going to multiply by 60, and that comes out to be 53.240312 blah blah blah. That 53 is representing 53 minutes. And now this extra fraction here, this decimal, is the fraction of a second I have. So I'm going to take that number and subtract 53, and I get left with all of this 0.240312 blah 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 stuff. I'm now going to multiply that. I'll change my color here. I'm going to multiply this here by 60. And that will then tell me how many seconds. And that comes out to be 14.418 blah blah blah. And I'm going to call it 14.4 seconds. I could round to the nearest second and call it 14. I could round to the nearest tenth of a second. But there we go. And now we have 3 representations of the exact same angle. 3 radians, that's the same or similar to 171.887 degrees, which is pretty darn close to 171 degrees, 53 minutes, and 14.4 seconds.